Find the area of the region trapped between the curve y equals x, x minus 2, x plus 3, and the x-axis. So if we think about this cubic, and we do a quick sketch, we can see from the factorized form that we'll have intercepts at -3, at the origin, and at 2. And because the x cubed will be positive, that curve must go this way. And so the trapped area that we're trying to find is this area here. And since some of it's above and some of it's below, we'll need to deal with bits separately. First of all, let's expand this thing out. So we've got x, x minus 2, x plus 3. So that's going to give us x into x squared plus x take away 6, which is x cubed plus x squared minus 6x. And if we integrate that, x cubed plus x squared minus 6x, then we get x to the 4 on 4 plus x cubed on 3 minus what would be 6x squared on 2, which will simplify to 3x squared. So if we look at this, which would be the integral between -3 and 0, without writing it all down, what we're going to have is x to the 4 on 4 plus x cubed on 3 minus 3x squared between -3 and 0, which will give us 0 when we put the top limit in, take away -3 to the 4 on 4 plus -3 cubed on 3, take away 3 times -3 squared, and calculating that gives us 63 on 4. And it's positive because that bit is above the axis. Now if we deal with this bit, that will be the integral from 0 to 2. And so that one is going to be 2 to the 4 on 4 plus 2 cubed on 3, take away 3 times 2 squared, take away 0, which gives us negative 16 on 3. And so the total area would be 63 on 4 plus 16 on 3, and we'll just calculate that, and that gives us 253 on 12 square units. Now we were talking about the class pad before, and so if I just bring in my class pad, let's just resize it so that we can see it nicely in our window. And so we can find the integral just here. And what I'm going to do is I'm going to integrate it all the way from -3 through to 2. And I'm going to put this in a modulus. So just here. And let's just do the function. It's x minus 2 and x plus 3. And I need to tell it that I'm integrating with respect to x. And there you go, 253 over 12. So if you're on the class pad, you can use the modulus. You don't have to worry about the positive and negative parts.